Here in real numbers we are starting with a theorem. Let p be a prime numbers and a be a positive integer. If p divides a square, then p divides a. Now basically it is based on the fundamental theorem of arithmetic integer, which states every composite numbers can be expressed as a product of primes, and this factorization is unique except for the order in which prime factors occur. Now we have got this fundamental theorem of arithmetic integers. Now here it is given to us, or the theorem is this: let p be a prime number and a be a positive integer. If p divides a square, then p divides a. Now we are having here a, we are assuming let a is equal to p1, p2, p3 and up to pn be the prime factorization of a, where p1, p2, p3 up to pn are primes, not necessarily distinct. Okay, so we can write a is equals to p1, p2 multiplied with p3 and again up to pn. Now a square will be given by p1, p2, p3, pn. Again it is multiplied with this p1, p2, p3 up to pn. Okay, it means a square, which is equals to p1 square, p2 square, p3 square and pn square. Okay, means p is a prime and it divides a square and it divides a square, means a is a prime factor p is a prime and it divides a square. Okay, now therefore we can say p is a prime factor of a square. Now from the fundamental theorem of arithmetic, it follows that prime factors of a square are prime factors of a square are, we can say, p1, p2, p3 up to pn. Therefore we can say here p is one of p1, p2, p3 and pn. Means it implies that p is a prime factor of p1, p2, p3 and up to pn. Means p is a factor of a. It shows p is a factor of a. Okay, this way we come to understand that if we are assuming a p be a prime number and b a positive number, a be a positive number, if p divides a square, then p divides a. Okay, so this way we can have the solution of this theorem. Now here we are having another question which is related with the previous theorem. Prove that root 2 is an irrational number. Prove that root 2 is an irrational number. Now here we are assuming that root 2 is a rational number. हम कॉन्ट्रडिक्शन से इसको प्रूव करेंगे. रेशनल नंबर. ओके, then we can say then there exist positive integers a and b such that root 2 is equal to a upon b. Okay, where a and b are co-primes. A and b are co-primes, that is their HCF is 1. Okay. Now here we have taken this, we are going to square it, squaring both the sides, squaring it. So root 2 is square, which is equal to a upon b whole square. Now here what we have got? 2, which is equal to a square upon b square. Okay, now we can have this 2b square, which is equal to a square. Now see here, 2b square equals to a square means 2 is a factor of a square. We can say 2 is a factor of a. Since we have taken 2 is a factor of 2b square and we are assuming, and we have got this 2b square is equal to a square. Therefore we can say this. Now we have used this theorem, the previous theorem just we have discussed here. Okay, so if we are assuming here again a is equal to 2c for some integer c, for some integer c. Okay, now again we are having this, squaring it, a square which is equal to 4c square, squaring it again. Okay, now here we know that a square is equal to what? 2b square. We can substitute it here. So what we are getting? 2b square is equal to 4c square. This we have got a square, which is replaced by this 2b square. Now ultimately what we are getting, 2b square is equal to 4c square. Again what we are getting, 2b square is equal to 4 square and b square is equal to 2c square. Okay. Now here we have got b square is equal to 2c square. Now we can say 2 is the factor of b square, because since we have got this 2b square which is equal to a square, so we can say 2 is the factor of b square, and similarly 2 is a factor of b. Since we have got 2 is a factor of 2c square. Okay. Now from this two equations, which one? This we can say it is equation 1, and we can say it is an equation 2. From it, what we have got? From these two equations, I am writing it here. From equation 1 and 2, we got that 2 is a common factor. 2 is a common factor. 2 is a common factor of A and B. But our contradiction here is this, that A and B have no common factor. A and B have no common factor except one. We have got this here, HCF is 1, means our assumption is wrong. Our assumption is wrong. Our assumption is wrong. We can write it here. Is wrong. Therefore, root 2 is an irrational number. Root 2 is an irrational number. This way we can go. If root 2 is given to you, now if root 3 is given to you, we can go in this way. If root 5 is given to you, we can go like this. Okay, this way we can prove that root 2, if root 3 is given to you, you can go root 5, and whatever root type of questions is given to you, we can go with this. मतलब हम इसको इस टाइप से कर सकते हैं. Okay. Now here we have got 3 root 2. Prove that 3 root 2 is irrational. Now we are assuming, again we will take the contradiction, that 3 root 2 is rational. We have assumed, let 3 root 2 is rational. Yeah. So we can say there exists co-prime positive integers A and B such that we are taking this 3 root 2 which is equals to A upon B, like this. Okay, now what I am going to do, I am taking this root 2 here, keeping here, and this I am transferring here in the denominator, A upon 3B. Okay, now we know that root 2 is a rational. Root 2 is a rational number, Now see here, since 3 a and b are integers, therefore a upon 3b is a rational number. Is a rational number. Is a rational number. Now this is the contradiction again. This is the contradiction again. Okay. That root 2 is irrational. It is a contradiction. Our assumption is not correct. Our assumption is not correct. So 3 root 2 is an irrational number. Okay. So this way we can go to prove 3 root 2 is a irrational number. Now we have another example. Prove that 5 minus root 3 is an irrational number. We have gone through root 2, we have gone through 3 root 2. Now here we are having 5 minus root 3 is an irrational number. Now again we will be having a contradiction. That we are assuming 5 minus root 3 is irrational. Is a rational number. We are assuming this. Okay. Now if we are assuming that, then again we can say there exists co-prime positive integers, co-prime positive integers a and b. A and b, such that we are getting this like 5 minus root 3, which is equals to a upon b. Now here we can shift this here. 5 minus a upon b is equal to root 3. What we did? We have shifted this a upon b over here, and this minus root 3 here, it has become equals to root 3. Now see here, if we take the LCM of it, here it is 5b minus a, which is equal to root 3. Okay. Now we know that root 3 is a rational. Root 3 is a rational number. Means our contradiction, it contradicts for this. What is a contradiction? That it is a rational number. So we can say our assumption is incorrect. Is incorrect. That our assumption is incorrect. We can write here now 5 minus root 3 is irrational number. Now see here what we have got. We have got this 5b minus a upon b, which is equal to root 3. And root 3 is what? It is a rational number. Okay. So what we can say? That our assumption is incorrect. 5 minus root 3 is irrational. यहाँ मैं लिखना बोल रहा हूँ irrational. Root 3 is irrational. Okay. I think, yeah, now it is cleared